Lesson 5 is on chemical equations and mass conservations. So we're going to introduce to you chemical equations. We're going to figure out how to read chemical equations, and then we're going to learn about conservation of mass. So a chemical equation is how chemists write out chemical reactions that are taking place. They always involve reactants forming new products. Here's a chemical equation. And the first thing that we notice are the physical states written after each compound or element. Okay, so we have HCl, which is aqueous, mixed into water, plus zinc, which is solid, which becomes zinc chloride, aqueous, and hydrogen gas. Now, anything to the left of the arrow is going to be considered your reactants. The arrow is what we call a yield sign or the creation sign. And then anything to the right of that yield is always the product. Okay. So now we're going to try to figure out how to read this properly. So when you look at this, you have to also look at the physical states, not only the reactants and the products. So when we see this, starting from the left to the right, we see aqueous hydrogen monochloride and solid zinc creates or yields aqueous zinc chloride and diatomic hydrogen gas, commonly known as hydrogen gas. Another example would be Fe2O3 solid plus C solid yields Fe solid plus CO2 gas. So now we're going to read this properly. You need to know the charges on that ionic compound because iron is a transition metal which has multiple positive charges. And if you recall, we need Roman numerals for that. It is solid iron 3 oxide plus solid carbon, which yields solid iron and carbon dioxide gas.
So the next thing we have to analyze in doing these problems is the conservation of mass. And the conservation of mass, which is something that we've all known about since a very young age, is that the conservation of mass is simply a principle stating that mass can neither be created nor destroyed. Have you ever seen your favorite show and your characters are shooting like fireballs or icicles out of their hands? It's physically impossible to do this because where is this stuff coming from? That if you were to basically evolve like, let's say Pokemon, like a Pikachu to a Raichu, and they get massively bigger, where's that mass coming from? It has to come from somewhere. So the reactants will always have a mass that is equal to the mass of the products. So if we look in our example of the aqueous hydrochloric acid and zinc being mixed to make zinc chloride and hydrogen gas, you'll notice, let's say for example, we have 40 grams of one plus 20 grams of another. It'll give you 50 grams of the aqueous and 10 grams of gas. But together, they have equal masses on both sides. Now this is just a theoretical example. So sometimes simple math can determine the amount of a reactant or a product. So in this case, we have solid magnesium and gaseous oxygen, and it creates magnesium oxide, which is a solid. Now, let's say that between our magnesium and oxygen making our products, you have 48.6 grams of magnesium, but we don't know how many grams of oxygen we have. However, we can weigh out our final product, which is 80.6 grams. Very simple math we can use right now to determine how much of the oxygen gas we needed. So if you subtract 80.6, which is your products, minus one of your reactants, you will get the different amount of 32.0 grams, which represents how many grams of oxygens were needed to complete this formula.
A block of wood with a mass of 134 grams and 101.0 grams of oxygen gas are heated inside a closed container. After several minutes, the heat is removed and remaining in the container 97 grams of charred wood and soot and an unknown mass of various gases, including oxygen, carbon dioxide, and carbon monoxide. What is the total mass of these gases, assuming nothing entered or left the container during the reaction? So remember, mass cannot be created or destroyed. So first, start with the reaction that was given to us. So block of wood plus the oxygen yields charred wood plus soot plus various gases. Now we know the block of wood is 134 grams. The oxygen was 101 grams. We know the charred wood and soot together came out to be 97 grams, but we don't know what the various gases were. So we add the block of wood and the oxygen, giving us 235 grams, and we're now going to try to figure out how much various gas we are left with. So you subtract the 97 grams from both sides, and we find that we have 138 grams missing on the product side, which would represent the various gases.